The feedback we get from controllers from whether it be this conference, from Recurrent training, or from any surveys that we take is the controllers want to know the pilot's perspective. They want to know that when they give a control instruction, what exactly is going on in the cockpit. Now, it's funny I say cockpit because I was just talking to someone the other day and I was told you probably should use flight deck from here on out. Now, obviously, we all have something to learn. This is one of my favorite panels. I am honored to be able to moderate this panel again. My name is Dawn Johnson out of Atlanta Center. And with me today, I have a controller out of the West Coast over there. And he's got a little bit of an angry face. He also, oh, you might have seen him in the Flyer magazine that's out there in the reception hall. He also looks a little like Sling Blade, but don't tell him I told you. Please welcome Richard Kennington.
You can't escape it. Oh, Lord. My name is Richard Kenton. I'm from Portland Tower, and apparently I appear very angry. But I'm honored to be here. You know, I got to represent NATCA at Oshkosh this year. If you've never been to NATCA or Oshkosh, if you've never been to Oshkosh, it's a great event, and I highly recommend you take the opportunity. I was working at the booth there where we answer pilot questions. General aviation pilots, they come in, they ask questions, and we answer them. And I was talking to a lady from Texas, and I was answering her question, and she stopped me mid-sentence, I thought very rudely, and she said, "Son, I can tell you are an air traffic controller. You talk really, really fast." And I said, well, I apologize, it's habit, it's just nature of the trade, is what we do. It's a hard habit to break. But I realized something through that experience and many others, that it's really important that we have these discussions, these pilot controller discussions, that we learn to understand one another. So I'm really excited to hear what our panelists have to say today.
So let's not delay this any further, otherwise we will get blamed for an ATC delay. Please welcome our panelists. First one is Brandon Johnson. He's NACA's Northwest Mountain Regional Safety Representative. We have Matthew Cain, Safety Chair for Southwest Airlines Pilots Association. John Murdock, NACA's National Procedures Representative. Paul Flynn, NetJets Pilots Group. Erin Phelps is NACA's Central Service Area ATSAP ERC Analyst. And Don Dobias, Air Traffic Services Chairman for Airline Pilots Association.
Yay. I'd like to start this one off with a video, actually. Now, I don't know if you guys knew this. I didn't know this was a thing, but there's this flight simulator. It's an online game where numerous users or players can patch in, and somebody plays the part of a controller, and then there are numerous pilots, and these are people in their pajamas at home, I'm sure, with zero experience. But I captured this one because, and I think you will identify this individual in your facilities. Tell me if you recognize this. Wait for it.
1492, advise ready to copy.
1492, ready to copy.
American 1492, you're clear of the Dallas-Fort Worth International Airport. Via the Kent U2 departure. Climb maintain 5,000. Initially expect flight level 27010 minutes after departure. Going to be 127.35, squawk 2454.
Climb maintain 5,000, something 10,000 after departure, then yeah, that's all I got.
Readback is correct. Advise ready for taxi information, Gulf current.
What?
American 1492, ready for taxi.
American 1422, runway 24 left, taxi by Juliet Lima Whiskey, advise holding short.
Repeat, somebody joined.
Readback is correct. Now that's efficiency right there, boys.
That's pretty. The funny thing is that each one of you can put a name to that. So let me start off with you, Matt. Let me give the first question to you. You know, on the ground, we know that the load on the flight deck is high. You do your pre-flight, everything else. Tell us what happens when you're cleared for the pushback. What progress starts to happen on the flight deck?
Well, ideally, before we get to calling for the pushback, we've completed all of our checklists. We, using some of our FDAP data, we've seen that one of our biggest problems is getting to the runway without flaps out. We want to make sure we have everything done before we get to the runway. So we start that early on before we even ask for the push. So 95% of everything we're going to do barring any changes, is done before we even ask for that push clearance. And then after the push clearance, we're focused on operating the aircraft only. Hopefully there's not as many changes. We have one last call to the flight attendants, make sure they're ready. But outside of that, we should be pretty well done by the time we ask you.
When we put you on the runway, what kind of checklist, what kind of procedures do you have when we put you on the runway?
Well, hopefully, by the time we take the runway, we should have done all the checklists. If we're still doing checklists on the runway, we're breaking some of our own policies and probably some FARs.
I've heard certain aircraft or certain pilots refer to a pre-departure checklist when they're ready to roll.
Right. We operate that checklist. It's one of our. It's a checklist we do for about a half a mile from the runway, about 2,000 feet from the runway.
Okay.
We operate that checklist, and that's basically verifying all the other checklists we've done, making sure that everything that's really essential for a safe takeoff is been completed.
Now, when we put aircraft onto the runway, a lot of times we're using gaps, 5 mile, 4 mile gaps, and certain aircraft roll a lot faster than others. Do you know why that is?
Well, I can tell you probably don't have that problem with Southwest. I think we're usually we're usually ready to go. We're usually the ones calling you, but that's because we've taken care of all that well in the past.
Yeah.
Have that ready to go. So if you see us barreling towards the runway, that's what's going on there. But there are times where we're not able to do that, in all honesty. There's times where we have a flight attendant call and say somebody's using the restroom, or we have flight attendants that are new and they're not as fast, or the taxi length itself. The taxi may only be 2,000 feet, and by the time they get the opportunity to do the briefing and stuff, they just don't have the time to finish by the time we get there. Okay. And it also depends on, some of our captains are, let's call them vintage Southwest, and they know how to operate a lot faster than as far as the actual movement of the aircraft. I just upgraded to captain, and I taxi very, very slow, so it can also be that as well.
Got it. Now, another thing we do is a lot of times when we taxi you out, sometimes we tell you to expect a certain runway on PDC, CPDLC. What happens when we change that on taxi out?
So that depends. If you turn the whole we can request a certain amount of runways, and generally the good pilots will request as many as they can if they have an idea of what's going on there, or they will request a certain intersection. So like in Atlanta, if we request the Mike 2 intersection, we've already got that loaded up, and it's just a simple matter of one pilot goes heads down, or the first officer goes heads down, and we'll change the runway if it's already loaded in our computer system. If you change to a more obscure runway, or you change the actual direction of the airport around, that can take a lot longer because we've got to send off for that information and wait for that to come back. And sometimes it takes longer than others. Sometimes it can come back in seconds. Sometimes it comes back in 5-6 minutes.
Another thing, on that same note, another thing I've noticed lately is pilots are refusing or unable to change runways farther out on final approach as well. So we used to be able to, years ago, we'd have no problem getting pilots to accept a new runway 4 miles in, and now if we don't give them a new runway assignment, sometimes as high as 10 miles out, they're like, no, we're not going to.
Well, and that goes back to having to request that information in advance. We also do the same thing on landing. Now, generally, we have an idea of what's going on at cruise when we're asking for that information, or just before top of descent. So we'll have that ready to go, and that makes it a lot easier.
Okay. What about an abort? What do you guys consider an abort?
Well, anytime we take the runway and don't take off, that's a rejected takeoff for the most part. There's some exceptions to that. But for you guys, the thing that we've had a couple of incidents where the controller has called the abort, or to ask the pilot to reject the takeoff, and there's been some times where it's either not heard or the pilot deems it's safer to continue. Mm-hmm. So the one thing we would ask from a pilot point of view is, if you are going to cancel a takeoff clearance, do that in plain language. Yeah. And be very
clear.
Usually, folks are pretty motivated on your end when they need to cancel a takeoff clearance. It usually happens pretty quickly. Yeah. But if you've got another aircraft crossing in front of us at the end of the field and we're already doing 100 knots, it's probably going to be safer to
just keep going.
To keep going. But that's why we make those decisions or whatever.
Is there any hard, fast rules for when you would consider an abort, like you can't accept an abort?
Well, after we reach every takeoff that we do, and it's based upon the weight and weather and everything else, We have a takeoff decision speed, and once we reach that speed, we're required to continue to the air, unless the aircraft just will not fly.
Yeah.
And then,
So when you guys get the end and you say you don't have your numbers, is that the paperwork, like the runway information?
right, the electronic
Okay.
bay reserve. And the other thing, to go back to that, is sometimes the weather itself will change, and the runway condition will change, and then we will have to send off for another report. So that can be, if it's 55 after the hour and you come back and tell us an ATIS and the runway condition has changed, then that's also gonna please tell us though, don't hide that information. But we do have to go back in and change some things if the slickness of the runway changes.
Okay. And then going back to your pre-departure clearance, how has CPLDC changed from PDC versus over the voice?
Well, it's helped tremendously because we've got it. It's right there. You've got the clearance. We're able to get everything we need. So it's really helped out. In fact, some of the guys that get so used to that go to airports that are only CPDLC, and then they go into a market where there's not even PDC, that it gets to be some of the situations like your controller there on the video.
So I appreciate that. So the lack of verbal cues and whatnot, that you don't view that as a problem?
Well, I think what we've seen on some of the ones with the clearances, when you are at these airports where they don't have PDC or CPDLC, or even if it's gone down, the controllers, usually those frequencies are now combined because they're used to not having that workload. So you're having to get in and get a clearance on what's probably now they're working ground and clearance delivery, or you've got another controller in there that's working something else. I mean, sometimes especially when it goes down, that's when you really have the issues trying to get in, when everybody's trying to get a clearance. I
appreciate that.
I have a comment, and hopefully it's just supplementary to what Matthew said. During pushback, the workload is actually very low. And that's because there's one focus there. We've got a team of probably 2 to 6 people around the bottom of the plane, and if some change comes in, I don't care. And I actually turn off the air traffic control frequencies, and I'm not listening to that. And I'm making sure I synchronize my activity with the parking brake and the braking systems of the plane to make sure we do not hurt somebody, as well as, there's equipment that could be damaged if we mistime the application of the brake. So that's one thing. There was another thing mentioned about takeoff timeliness. A typical sequence, for the airline that I'm in, we do operate a wider range, and often the planes are loaded so full, they're right at max capacity for takeoff performance. And so a typical sequence would go like this. You clear me for takeoff, someone says, I'm cleared for takeoff back. Then the pilot who's manipulating the controls that day gives a nod or some verbalization, perhaps, here we go. And then we move up the thrust levers to an intermediate position. There's a pause there, and I happen to be a gatekeeper, so I know that this pause takes 6 to 8 seconds to allow the engines and the pilots to make sure the engines are achieving thrust symmetrically. So one of the big things about for a takeoff is you want to have both engines running, and you want to have them symmetrical so you won't have lateral control problems during the rest of the takeoff roll. Then you move the thrust levers toward your takeoff position, and you usually, if there's auto thrust involved, you engage the auto thrust system. It'll take 20 seconds from the time you start thrust levers or throttles from the idle position to where you even set and start to achieve the actual thrust that you need. In the middle there, you won't even detect the first knot of movement different from what you had before you started the thrust change for about 6 to 8, maybe 10 seconds. And this is typical across most turbojet airplanes that I've looked at. I've looked at 40 or 50. We did a special study. One of our airplanes kind of almost ran off the side of the runway, and it was because guys were just pushing the throttles up. And then guess what? One engine did not go up symmetrically. So there is that pause. And one of the things what I learned in the study was you don't even achieve 35 knots for like 25 to 30 seconds after you say cleared for takeoff. So there is that pause in there, and this is a function of inertia, load planning, and the numbers that we receive, there may be a dynamic with load planning that occurs, and sometimes that's a cause for delay as well. So I just wanted to add that in. Nothing you said was wrong or anything, but there is more to it than, there is the Southwest way. But I think the laws of physics still apply.
We're very proud of that way.
and there's no aspersions meant there at all. I'm just saying that explains a lot of the other delays and lags you see there. Thank you.
Appreciate that.
So I want to talk a little bit about climb via, descend via, right? There's a lot of people that want to know about this. The phraseology, which has led to numerous issues and caused lots of safety concern. So John, on the controller side, what have we done to mitigate these issues?
So I think we've seen initiatives from like Partnership for Safety and the ATSAP team get out there and address some of the concerns with the workforce and properly applying a climb via or descend via procedure. We've also seen some online-based training that we put in front of the controllers and even Recurrent. So we continue to see some issues. I think we're getting better. We have some movement to make, but we're going to keep putting it out there and try to clarify exactly what needs to happen and help the flight crews out. And so Paul, for you guys, what are you seeing training on your end for climb via, descend via?
Well, this topic seems to be nothing new. We've been trying to solve this riddle for a number of years now, but we've also used our safety reporting tools and systems as well to introduce it into training, to work with it consistently, and also I know we'll talk about how it takes place in the cockpit when we're removed or brought back onto an arrival or departure. But I do like that it says here, what are pilots so confused about climb via the SID? The climb vias are fine. It's the descend vias that confuse us to no end. And just to make light of the humor, there's been notes from within that how you handle it. It should be something simple, right? Climb via or descend via. You climb via, you pick the highest number published, you dial it in, you press the fancy climb via button, and off you go, right? Descend via should be the same thing. You find that lowest altitude on the arrival, you dial that in, you press the fancy descend via button, and you're ready to roll. What ends up happening more often than not is the systems on the airplane have their moments just as much as we do. And somewhere in someone's history, a pilot may have felt that they were burned by how the system processed or did something, and that trust level with the automation broke down a little bit. So instead of seeing what I just said, where they say descend via and you set the lowest altitude of, say, 6,000 feet, they'll look at a next crossing altitude, and they'll dial that in as an insurance policy. And anyone in the room here can probably begin to predict where the errors start to back up on that, because now you need to stay ahead of not only your setting of the altitude, but also the automation's sequencing of it. And the same we've seen too with departures, same idea, where if you have especially a low level off, one that's below 2,000 feet AGL, they will set that first level off in, for lack of a better term, the hard-coded altitude, not the one that's provided by the flight management system, as a safety, because somewhere in their history they've probably been burned by it. I don't know if you have anything to add on that, but one of my questions for John was, what is it from the controller's seat that they see us screwing up the most? Like, what errors? Yes, I know, right?
I don't know if we have that much time. How are we going to be here a while? No, I think climb via, descend via, I think the common cause. I don't know if it's more on our end or in the flight deck if that we're coming off a procedure and getting back on it, right? Yeah, if we're climbing or descending, I think that's where we're struggling the most, of recapturing the routing and the flight deck and the aircraft doing what we expect. Now, I think there's some issues. We're still failing to issue some altitudes at times if we're taking you off on an arrival or a climb via or descend via. But as we clean it up, I think that's where we're struggling a little bit. I don't know that we've identified exactly where it's at, but I think getting you back on the route and then lateral conforming laterally and vertically to the procedure is important.
And to speak back, so that's exactly where I figured that, nav and altitude deviations have always been the top two across the board. And the safety reporting systems show this, where, I'll try to keep it brief, but when you remove a crew or an aircraft from an arrival or a departure, it's pretty straightforward. You give us a heading, an altitude, maybe a speed, and it goes very basic. We set that under the heading bug and hit the button, and we set the altitude that you've assigned and select that as well. though we do need to change the modes. The plane at this point has been following the computer on the arrival, which we can only use directly from the computer's database. We can't build these from scratch. So we've loaded it, and everything's been going fine, but you need us to step off of the arrival for some particular reason. We do that, we end up in these very simple basic modes of heading and, say, a vertical speed. We just tell the plane how fast we want it to descend instead of it calculating it for the arrival. When the time comes for you to re-clear us to join, this is where the errors start, and there's a couple of things that compound that. You'll give us an intercept heading to rejoin, which we'll set that heading, again, in the same concept. We also need to tell it when the time comes to rejoin that course, and that is one of the paramount places we miss. We have to verify that. Altitude is the next issue, right? So you told us to rejoin the arrival, and most likely told us to continue via the arrival and descend via it, where we need to stay ahead of that and then set the lowest altitude. And here's where the technology fails us a lot. As I said, we pull these procedures out of the database that is baked into the system, and as we've been not flying that, i.e. in just in the heading and basic mode, we have to hope it's sequenced. We had to hope that it kept doing the arithmetic along the way so that when we do rejoin, it does it correctly. And a lot of times, it doesn't. It is either behind or you joined it with not enough time. So it says, okay, I'm now on the arrival, and it grinds through the math, and it either ignores the stop and just continues descending, or it just leaves you out to dry. And that's where I know Rachel on the previous panel just commented on what we would call the housekeeping or the administrative aspects of the flight deck. That CAMI, that acronym, confirm, activate, monitor, and in all cases intervene. And it's that intervention part that really saves your day. So I hope that answers a good amount of what you see on our side in the cockpit. It's a lot of moving pieces, especially on the rejoining, and hopefully, as I alluded to earlier, trusting in the automation a little bit, rebuilding it if it has in fact burned you in the past.
If I may add to that, I'm sorry. Part of the function of maybe not being as adaptive in that situation as we'd like to be is we don't really know where you're going to have us rejoin. We can't read your mind. And you don't necessarily have time to explain it all, and maybe you're kind of making it up as you go along as well. But then also, we don't train like that. We train to fly the procedure notionally, and we demonstrate that we can do that, but we don't necessarily have time in most of the training footprints that I've seen to actually go through and cover these variations and really talk through and learn through experience and repeat the various ways you can recover. So it's problematic to really generalize and then back up the old school monitoring your position with descent paths and things like that. So thank you.
I appreciate that. Let me just follow up on what Paul and Don said. One of our audience members wants to know, what are the adjustments being made on the flight deck when you get a runway assignment adjustment, change of runways? So what's happening on the flight deck?
So as these procedures start to kind of dovetail into one another, whereas arrivals are now more and more dependent on the runway you're landing, come back to that point where I said we have to load everything from the database. That just is a safety aspect of it. So if we have been all set from 18,000 down on an arrival that is indeed hinged to the runway that's landing, you'll love this. You'll say, okay, can you land this runway? It sounds very simple, and it is, but when you press the buttons in the flight management system and press OK, it will reset everything back to where you entered the arrival. It loads everything, and I know systems are improving, but it happens because it only sees these as whole parts of the equation. And then, as he said, you have to play catch up as to, okay, where are we? What's the next fix? And then do a little tidying up of that. And once that's done, then it can finally start to grind through the math. And these are not exactly the fastest processors. So that simple runway assignment, in and of itself, is not overly hard to wrap your head around. It's getting the plane back to where it needs to be after we've reloaded the information you've asked for. Believe it or not, it was a lot easier when you just flew to a VOR and then grabbed a localizer. And that was pretty straightforward.
Yeah, I have the same problem with my Diamond Katana. I sympathize.
I know you understand.
Erin, so in the terminal environment where I work, TCAS RAs are fairly normal. But in the en route environment, where do you guys see the TCAS RAs? What issues are you dealing with in the en route environment?
I'd say the most common one that I have seen or had happen when I've been plugged in is an aircraft in level flight with another aircraft that has been cleared to an altitude that would be positive separation. And I'm not exactly sure about how the TCAS is manufacturing its numbers or making its determinations, but the aircraft will be cleared to 1,000 feet, say, below, but somewhere in that climb, the aircraft that's level will report a TCAS RA. Now, I've called the traffic before this. Aircraft is climbing to center, we're getting an RA. I recall the traffic, so they know that's still the traffic that your RA is, at least as far as I'm concerned. And then I'll issue, when able, this is what I'd like you to do. Because I can't give you a control instruction while you're receiving the RA, but as you recover, to be somewhat expeditious because there's other airplanes, when able, advise, you're finished, and this is what we'd like to do next. But the first thing I do is tell them, regardless if it's a not expected RA, but a controlled RA almost, or if it's a not, the first thing I do is issue the traffic or the traffic alert to assist them in what they're doing.
So Dawn, if she's issuing you an altitude where the two aircraft are separated by more than the applicable separation, why do you want the traffic advisories from me?
The main benefit there is that we love to hear from air traffic controllers that you have our back. The essential safety function of keeping airplanes separating and avoiding collision is greatly appreciated. That is an understatement. The fact that you are monitoring so closely that you recognize a potential resolution advisory or even a traffic advisory before it happens, to us is a compliment to your ability to have awareness, situation awareness, and we greatly appreciate it. So never hesitate, advise if you see the need to do so. The TCAS advisory system, the traffic and alert and collision avoidance system, is built as a backup to your function. It's an automated function. Sometimes things do break down within the system that you have responsibility over and you have really exclusive control of. But with the traffic advisory systems, you know, the way the system works is there's transponders on each airplane and there's processors within each transponder. If the TCAS system is functioning, it calculates a point of closest approach to the other traffic. And then there's thresholds at which we are advised. So it's hard as a human being to maintain vigilance at all times. What's really great about the systems, and we hear orally that there's some traffic coming, it's a pointer. Be on the lookout for something. We can now focus our attention. Just like when I push back, I'm focused solely on protecting the people on the ground. I don't focus on anything else. Now in flight, I'm up in the air, I'm flying around, I'm stable, and maybe we're talking about retirement plans, or maybe we're talking about the baseball game that your son or daughter just played in, and then all of a sudden, focus. Yeah, with the automated system, it's going to trigger around 40 seconds out, and it covers an area that's up to 10,000 feet away from your airplane. It's going to say there's an intruder here that you need to be potentially more focused on than you would normally otherwise be. So it draws your attention to something. A resolution advisory, it gets a little bit closer, like within 20 seconds, and it's still the same altitude sensitivity, but it'll give you oral alerts, it'll give you visual indications, and it'll tell you something to do, and it's a prescribed set of conditions that responses that the company prescribes that we will perform in response to that. That's going to take us 5 seconds at least to get that done, and then maybe 10 seconds to resolve, okay, we're set up, and then we'll have our wits about us. We're supposed to make a call to you. Now, in the middle of that, you may have called us. We may not even have heard that because we're focused on responding to the RA. That's just human factors, considerations there. And then the recovery, yeah, we have an interest in being expeditious on the recovery. We'll do exactly what you say, and we trust you to give us that guidance in a timely manner. So Does that answer the question?
Well, it does, but if I can follow up that question, is your response then to a TCAS RA different if I have given you the traffic advisory?
Well,
if you
yes.
know about it.
Yes, there's a bound to it that's a known. It's based on an algorithm that's pre-calculated, and it minimizes the deviation. If you just tell me it's there, I don't have a good sense. Many times I'll see traffic advisories, I don't see the traffic. I don't see it until it goes by. It's still stated in an advisory condition. Resolution advisory, I'm doing something, and again, I may not even see it, but I'm going to respond to it. So the addition is I'm drawing my attention to an area where maybe I will have to take some measure that, because maybe the TCAS is malfunctioning. If I see it, I'm going to do something to avoid it. At high altitude, it takes some special, I did search and rescue for years in the Air Force. I was a helicopter pilot. It's hard to find things. And even when you think you have focus areas of sectors to search and you assign people duties, it is hard to find things. Even if something seemingly as big as an airplane, the imagery, the size of the image is not very big. And it's moving, and it's dynamic. And there's a background that's very dynamic as well.
I appreciate that, Paul.
I'd just like to add some color to that, just to simplify all this. TCAS is amazing, but it's fundamentally very simple. It just knows a time to impact. It does not know, in your example, that 1,000-foot aircraft is going to level off, or that you're going to level off in your descent. It just sees at this point, you're within 40 seconds or 20 seconds, and that's when it gives us either the traffic advisory or the resolution advisory. And to answer your question about does our behavior change if the traffic's called, we're taught from the get-go that even though we may have identified the traffic, we can't confirm that the one that the TCAS is telling us to act upon is the traffic you advised.
True.
So when we get a resolution advisory, I mean, there's two things. We hit the button, we follow the guidance, and we say TCAS RA.
There's still some uncertainty.
That's it. Only for the fact that we can almost be 99% certain that we're talking about the same traffic, but we can't, that last percentage is why when we get a resolution advisory, you follow it. And I hope that answers your question. And we have all manuals that have this little sentence that says, within 1,000 feet, and you see that there's traffic in the area, you're supposed to reduce our rate of climb. That's certainly something that would avoid that. But then we get back into the automation and how well that works all the time. So,
in the terminal environment below, what altitude do you stop getting RAs?
It's around 700 feet.
1,000 feet.
And to that point,
Or
there's
12.
certain terminal environments where, with my company, there's two different airports where we actually turn off that resolution advisory. We'll get the traffic advisory, but we won't actually have to follow the RA. So, like in San Francisco, where they're so close, under certain conditions we can do that. And also, Denver is an interesting place because you've got some carriers are turning it off, and some are not. So everybody is not on the same sheet of music as far as that goes. And there's some efforts to try to fix that.
I appreciate
That's a
that.
different panel.
So I wanted to circle back because we have some questions that the audience has. Circle back to the runway topic. Routinely, pilots tell me at the runway that they are not ready. Way too often, in fact. What can be done to get them to not even ask for taxi clearance when they're not ready? What do airlines mean when they say they don't have their numbers?
Well, the numbers was the takeoff data we talked about. So it's the speeds that we're going to make that decision out of whether we're actually going to go flying or not. And if something bad happens before that, we'll stop on the runway, and then after that speed we go. And a lot of that's predicated on that. It gives us our stopping margins and tells us a lot of different things that we need to make a successful and safe takeoff. And that's where we were talking about earlier with sometimes it comes back immediately and sometimes it doesn't. We generally have that information before we push at Southwest. Some carriers will go off the gate and don't have that information. They're waiting on it on the taxi out. And then good luck asking guys to not get a taxi clearance before they're ready. I mean, if you could guarantee us we could instantly get our taxi clearance and get to the runway without delay, we can work with there if we could start there. But I think the anticipation is we're not going to ask for a taxi clearance knowing that we're not going to make it to the runway and be ready. We're not malicious. Well, at least I'm not. We're not trying to get to the runway and block everybody from taking off. But by the same token, generally we know the airports that we're flying into, and that's, yeah, Southwest we're flying into 100 airports now, and so and every pilot can go into all of those airports with the exceptions of Hawaii and San Jose, Costa Rica. So you've got 90 plus airports these guys are going into. So some of that familiarity is going away as far as how quickly you're going to get to the end of the runway. But we expect that we're going to be able to accomplish whatever we need to accomplish by the time we get to the end of the runway when we ask for that taxi clearance. So if we have a couple of items that aren't necessary, that we need to sort out, we expect them to get them by the end of the runway. And I think that's more prevalent with like your United and those places where you are waiting on the numbers on the way out. I don't want to speak out of turn, but I think that's probably more.
Yeah, it probably happens about 1 out of 20 times, actually. Our company tells us, and I believe it, I've seen the improvement over time. We usually have the numbers before we leave the gate area, the area where we gather together as a herd and load everybody up. But it's actually rare from our perspective, but that doesn't mean it's still not aggravating. And once we realize we don't have numbers, I know once we approach, you mentioned within a half mile of the runway, we start going, well, should we confess? We start going, should we tell them we don't have the numbers? Yeah, I don't know.
And some airports, that can be a real problem because,
because you don't know if you're going to wait 3 minutes anyway.
Right, if you have to get looped all the way back around to the back of the line, especially if you don't have a parallel taxiway, or a parallel to the parallel, it can be a real problem. So
And then I have another one that seems to be popular. I read on the wrong surface operations fact card in our registration bags that the #2 principal cause of wrong surface operations is communication. Where the controller issues an amended landing clearance.
Oops.
That tripped up.
Right there at the top.
What are the adjustments being made on the flight deck, and is there a better way to address this issue?
I think to his point, 30, 40 years ago, you could do whatever. If you told us to land on a parallel, the runway next to it, okay, let's do it. No problem, because that was the mindset. Whereas now it's, well, we have to have the numbers. We have to have all the data. We've got to get everything completed. And you took the question away again. And then the other, I mean, we want to make sure that we can make that as safely as possible, but there's also a little bit of expectation bias. So if you've been telling us since 18,000 feet it was going to be 9 right, and all of a sudden at 1,500 feet you say, can you make, you're clear to land 9 left, or whatever, that can be a real problem. If we're expecting that runway the whole way down, and then we don't have all the data to be able to accomplish that. So we want to work with you, but we also want it to be as safe as possible on our end.
And to build on what Matthew's saying is we get a lot of pushback for what if it doesn't go well? It's a simple sidestep. It's so simple. And yeah, I mean, in theory, it's about the same length, the same runway, everything else. But let's say it doesn't go well and we're getting debriefed. They're going to ask, did you fully brief the runway? Did you look at conditions? It just goes on. And I think we've all gotten caught up in that bureaucracy as well. So that's why that sidestep or, something for all intents and purposes sounds pretty simple. If we didn't go through that start to finish performance evaluation, cross-checking configuration of the airplane, and then briefing, we put ourselves out to dry if it doesn't.
And it could be something as simple as a taxiway that's closed that you didn't brief at 18,000 feet, and you accidentally you turn off on, and then everybody's mad at you. So.
And I feel like the controllers have just as much to buy in on this one as the pilots do. Because a lot of times, like you guys said, telling you expect 9 right, 9 right, 9 right, and all of a sudden just throwing that random 9 left. So now we have that phraseology change that tells everybody you have to use the term change too. So the communication is much our problem as it is the pilot's problem. So.
And I will say this, though, that doesn't mean that this is off the table completely. It's just the heads up further back. So, hey, plan for 9 right, but will you be able 9 left if possible? And they'll say, we'll come back to you and say yes. Then we can brief for both in the event of, and it's covered. So it's not off the table completely. It's just the being made aware of it earlier out is what's going to make the difference.
Another aspect here going on in the industry that's very critical, at least to the pilots, is there's a greater sensitivity and less tolerance for variations from stabilized approach parameters. So speed control, track control is very sensitive within those last 5 miles, and part of that setup occurs 7 to 8 miles, so 3-4 miles prior to the 5 mile point that, we're saying no more often because of that.
I noticed.
So with our newer workforce coming in, there's less and less of us that are pilots. What kind of challenges do we create as controllers that make it hard for you to maintain speed restrictions, whether it be one that is on their approach plate or one that is issued by a controller? Let's go with Matt.
Let's go with me. All right. So with the designed RNAV arrivals that we've got now, everything is so predicated from we start at point X at such and such a knots at such and such 1,000 feet, and everything is supposed to go that way all the way to the end runway. And when we don't have that occur, it can really introduce a high workload in the cockpit, especially with some of our aircraft now with such the efficiencies of the wing and everything else. It's harder to get it to slow down and get down and achieve some of the things that you guys want us to do. If we know about it, we can try to work that out beforehand. It's the changes in the middle of the stream that become the issue.
So like with the go down, slow down, it's our favorite.
Okay. The go down, slow down. If you're going to ask us for a go down, slow down, have a priority in the back of your mind as to what you really want, because we may not be able to achieve both of those.
Which one do you want?
Yeah, I mean, sometimes you can have it all in this world, but not necessarily in the 737 with winglets, especially with the new Scimitars. I came from before I flew the 7.3, I flew a Douglas product or 717, and that would come down and slow down, and it worked very efficially. And when you get into the 7.3, I was having the same. I was like, well, it won't do the things that they're asking. It just physically won't do it. Mm-hmm. So you're going to have to give us an option there. And generally, if we can have a little bit more speed, we can accomplish that. It's the altitudes constraints just become very difficult. And also we don't, one of the things is we're not really told why you need these speeds. Some of them seem fairly arbitrary, and it would be kind of interesting to know more about, why do you need this speed 35 miles out and all, but that's we don't understand what you're trying to accomplish sometimes.
And you mentioned the Scimitars and the winglets, and a conversation we had yesterday, whatever it was, as we were preparing for this, we started getting on the conversation about how much those actually change the flight characteristics of the airplane. A lot of us controllers know, it increases fuel efficiency, reduces parasitic drag, stuff like that. But for us as controllers, I don't think we comprehend how much it actually changes the flight characteristics. Can you guys share a little bit of that?
Well, I mean, and that's the thing too. If you've got two 7.3s, one with winglets and one without it, and I can see your frustration in controlling them as to the different performances that you can see. It's a good-looking tie, by the way.
Thanks.
The advent of the winglet changed everything. The planes just became slipperier, for lack of a better term. They just don't slow down. So an old muscle memory that you'd expect, it doesn't happen anymore, and you end up in that behind the 8 ball. Whether you've kept us up for weather or for whatever reason, now where you're trying to catch up with that arrival, as you alluded to, it's usually one or the other. It's becoming harder and harder with the increased aerodynamics of these airplanes and how efficient they are.
Do you guys have a wind readout? Because sometimes there's some stronger winds than we anticipate, tailwinds that really frustrate, even if you're anticipating a steep angle of descent. You just can't do it because of externality. Maybe you could do it on a normal nominal wind day, but today there's a big tailwind. Do you guys have any sense other than ground speed readout?
We typically have the center field winds right in front of our display, and then we have the TDWR, which is terminal Doppler weather radar in the back, that if we have to get up when we have to go research, and it gives us different altitudes, winds at different altitudes, but it's not in front of us. So most of the time we just rely strictly on pilot reports. Well, we'll ask you when you check on for us 6 miles out, 10 miles out, whatever. Hey, where do the winds aloft? And that's basically all we got. So.
All right, we're going to introduce the next topic with a video.
How do you feel? Good?
Oh, no.
So as controllers, we issue wake turbulence cautionary advisories so often that they seem to lose their meaning. John, help us understand the differences between the wake turbulence and wake encounters.
Sure. That's jet blast, not wake turbulence, but pretty funny. So obviously a wake encounter is the result of encountering wake turbulence. Every aircraft that flies generates wake turbulence, produce a different strength. They're all different. It's largely based on weight of the aircraft and wing size. So what we look at when we're setting aircraft up for wake turbulence separation, tend to look at how much wake the aircraft generates and what the roll control authority of the aircraft is in the event of a wake encounter. So the scientists, real smart people, get together in a room and they put together and we classify all the aircrafts, heavy, large, small, maybe some recats classifications and whatnot like that. But Paul, what's important to you when we're issuing wake turbulence advisories? You're following a heavy 767, following an A388. What does that look like?
First and foremost, the advisories are not unappreciated. They certainly generate conversation, but I'll step it back to the area that we have the least visibility as it pertains to wake turbulence, and that's en route. We don't know who we're necessarily following. We don't know who's maybe crossing in front of us. So those are the helpful kind. And one of the things that if we know we're following somebody for the next 1,000 miles, wake turbulence has a really unique signature in the airplane. It feels very unique and you know what it is. And you can offset your course. And there's ways to work it, usually upwind. But down to your point, where we're in a terminal environment on arrival or even departure, and we know what we're following, it goes back to essentially what you learned from day one is you want to stay above the path of that aircraft, and it still works, touchdown past its touchdown point. Because wake turbulence is something to absolutely be respected. It is not something fun that you ever want to encounter because it will wake you up and it'll wake you up quick. The thing that we talked about earlier in the conversation that seemed to be not brought to the awareness of the controller community was how much winds impact the signature of an aircraft's wake turbulence pattern. The most dangerous of which being is a light quartering tailwind. Because if you think of these things, they're just like little tornadoes off the wingtips of an airplane. They get compressed and they get pushed down the runway, which is where you're going, and you're flying right towards it. And this happens quite a bit as, let's say that's a busy arrival period and the airport's starting to favor and it's having the tailwind configuration, but you're just waiting till the busy period's over before you turn it around. So that is probably the highest period, and I say anyone sitting here with me would say that when you see that condition, you're well aware of the risk associated. And with anything else, the windier it is, the more of a crosswind component you have as well, it clears them out. So hopefully that answers it. But we're very aware of especially who we're following, and those advisories are not unappreciated. They're not going to waste.
Yeah, understood. I know the en route environment, we don't have nearly the scientific data of what the vortice looks like and the strength of the vortice. It is a concern, and we've talked about some mitigations, but not much consensus right now on what to do en route. In the terminal environment, we're extremely aware of what's going on with wake, and it's definitely not something to be messed with. And right now the NAS contains 5 different sets of wake turbulence separation, which we're trying to trim that down with the agency and get back to one set so that pilots know what to expect. You shouldn't depart behind a 757 at one airport and have one standard and another airport a different standard. So we're trying to harmonize everything and get everything back in line.
You have any idea when that work will be complete?
Well, so we have the latest order. It's consolidated wake turbulence. And we just finished the NAC commitments. We know what the NAC commitments due for the NAS. And we've just recently started going back to original recap facilities to upgrade them to consolidated wake. It'll probably take about 2 years. And then we're hopefully shortly after that, we'll be able to incorporate the CWT into the .65 and provide the tools, benefits to the entire NAS of wake recap. It's going to be a little while, but we're going to get there.
I've got another question for you, because I've been seeing a lot of reports about wake turbulence in the flight levels behind 778s and 380s, and they're more than 1,000 feet separated. Are you guys thinking about doing stuff with that?
Yeah, there's been discussion, especially the upper heavies, or the heavier heavies, 600,000 pounds or heavier. They generate a lot of wake, and again, we just don't have the scientific means or data to adjust anything. So wake turbulence separation, most importantly, it does not prevent a wake encounter. And I think that's a misconception in our workforce and actually the pilot's workforce. Wake turbulence separation actually mitigates a wake encounter. So it does not put the aircraft in an unstable or catastrophic position. So you can, may, and will experience a wake turbulence event with the appropriate separation and sometimes even more.
I appreciate that. Before I go into the next topic, I want to address one of the questions, and Matt, I'm going to throw this to you for obvious reasons.
Right.
I was invited by SWA to speak to their captain upgrade class last week in Dallas. 20 brand new captains were floored when they learned the controller is responsible for the accuracy of pilot readbacks. What can we do to improve awareness of needs on each side of the mic to be successful in our job duties?
Well, I can tell you that anybody that's been through had to fill out an ASAP report for a readback, hearback event is well aware of the controller's duties. But, you know, I don't know, short of, a lot of times, especially in Atlanta, some of the controllers are very, have to hear it back exactly. And I think that trains some of our pilots, for lack of a better word. Every day's a training day, so it trains some of our pilots on that. Is that they've got to read it back correctly. But then there's some that are pretty lax about it, and there's not as much consistency on that. And but sometimes you'll hear guys on the radio, controllers on the radio, say, "Hey, I have to hear that back exactly like I said it." And I think it's pretty powerful when they do that. I know that workload doesn't always permit that, but that's a pretty good technique, just right on the spot when you're identifying that one individual.
That actually segues into one of the other questions I had, but I remember in flight training for me, the entire training I got for speaking on the radio to air traffic control was who you are, where you are, and what you want to do. That was it. That was the extent of my entire radio communication training.
Right.
Is that changed as you get farther up in pilot training, or how do you guys train to talk on the radio?
I think it's just more people get more comfortable on the radio, and they don't rehearse. When you're a private pilot, you have that script in your mind. You're rehearsing. You're preparing for every radio call, and you're doing that. Well, you might be getting a cup of coffee or something. While all this is going on, you just say, "Hey, okay, we got it. Great. We're cleared at 270, whatever." It's not as okay. I got to make this radio call right now. It's just more.
I think to improve awareness, we need to have. I mean, it'd be lovely to have an event like this, like every 3 months or something. Sharing the perspective, listening and hearing the concerns on a systematic basis is outstanding. And I would love to see more and more controllers, somehow if we could make it easier for them to get access to our flight deck so they can come in and be part of it and be a witness, say this is how it looks to us when this dynamic is happening. And then, likewise, thank you very much, thank you. And then the other thing is pilots need to take the initiative. I encourage this all the time, and I've been to towers, I've been to grounds, and different times in my life and en route centers. I just love going in there and learning what's going on and just gain such an appreciation for really the work and the systematic processes that we have in here to make this thing go safely. Efficiency is a good thing. I like that too. But the safety and all the concern, it's good to see and experience that face to face, eyeball to eyeball. And I think that's a way to really improve awareness and appreciation. Thank you.
Thank you. Well, so I want to go on to the next one. And Don, I'll come to you second, but I want to go to Erin first. And basically, it's a simple question. Recurrent training is near and dear to my heart. What is the training culture like in your facility?
Towards Recurrent? Well, there's room for improvement, to put it generously. I would say it's curious that controllers get certified, and then we become untrainable, or so we speak. We don't need any more information. We got this. I already know everything because we reached certification. So in training, we need to be willing to receive information, but we get certified and suddenly we're done. And really, that's unfortunate, because with Recurrent training I have the pleasure of knowing you, so I'm always very proud of the work you put into it. And there are individuals on safety teams that are putting this information together, because the data received says that we need a little refresher on this. We need to touch ourselves up. And training and wanting to receive that shouldn't be viewed negatively. We should receive it positively. I mean, really, we discussed if somebody offers you a breath mint, you don't say no. So if somebody offers you training,
that's going to be on the t-shirt for next year, by the way.
Big takeaway, big takeaway.
So, I mean, we really shouldn't say no. And I think what happens too is realizing the data that is collected that drives what we're learning is the controllers telling us, hey, we're seeing this pattern, these mistakes are happening. It's not randomly just pulled out of a hat. And in addition to that, the pilots are saying, these errors are occurring when we're in the air, and the data is telling us, yep, we need a refresher on that. So let's accept it, and let's take it, and let's do better and be glad we got it. Because I know in the last Recurrent, when we're going over different phraseologies for encountering terrain, and it's like, I haven't used that for a long time. I'm really glad I got it. Thank you, Richard. But I think, too, is let's embrace it. And then also, when you go back to your facilities, be a voice that can speak positively to it and drive a positive conversation, because the workforce around you is listening. And the new controllers and the next generation, they're listening that somebody is going to speak positively and be willing to stand up for training isn't bad. There's nothing wrong with having information coming to us, and we should be proud that we're putting it together and we have teams of people driving that, and that we're willing to receive it. Because like this panel is telling you, they count on us and they trust us 100%. So let's be okay with it.
Don, what's the pilot's attitude? How is recurrent training received from pilots?
There's an element of fear, and there's an element of respect. And it's a training program is a function. There's formal functions, systematic, and then there's informal functions. One of the best regulations or guidance I ever read was in the Army manual about crew resource management. And it says that the primary trainer in an aviation company is the pilot in command. And it reflects the power of your peers to actually be trustworthy enough to correct and help you gain proficiency in things where you need to be developed more. And so when you're on, that's really the spirit of on-the-job training. So that's actually the most, in my opinion, the most powerful force out there. As a system, it's really good that we have feedback loops now that tell people who can develop training programs, well, we need to be a little more organized about that. In aviation, it's called an advanced qualification program, and at the end of it, there's actually a check ride where and it tends to take a month in most programs in an airline. So for a month, you were absorbed with learning about a new plane and a new way to operate in maybe the same old airline system or maybe a new airline system. But at the end of that, there's a check ride, and if you don't pass, the FAA is notified, they give you some remedial training, and there may be a little bit of embarrassment involved, but always in the systems that I've been involved with and seen, you're not fired as a result. So there's a sense of hostility, there's a sense of I could embarrass myself, but there's accountability with that too. And yet the way you can cast it to a person is, your failure, within each failure is the seeds of your future success. Because then you identify, you can really focus on the area where you need improvement, because with the help of a properly trained instructor or an examiner, you're going to be able to learn something from the experience you've experienced in the training program. There's multi-layers in the training programs. Every 9 months, some airlines do every 6 months, some airlines do every year, but 6 to 9 months, you're going to come back into a simulator and you're going to have at least a day, if not 2 or 3 days, and you're going to get focused experiential training as close as you can without actually, scaring yourself flying in wake turbulence and say, okay, let's go experience that, or let's go experience a big wind shear and see how you do. We're not going to do that in a real plane. We do that, but that's real. That's not training. And they're going to identify and they're going to have good critique systems. Then we have, in addition, every trimester we do supplement that with cognitive development, awareness, knowledge, computer-based training. And then we fly with pilots who every day, Frank alluded to it with the 5-minute debrief, and so we've shortened the 6 minutes to 5, because we're so damned efficient. Anyway, we sit there and we purposely try to identify strengths that we saw and demonstrated during the flight. We try to identify areas where we need to improve, and then we actually try to verbalize and express to each other systematically, and we can do all this within 3 minutes. By the way, once we go to the bar or the restaurant or whatever, which often is the normal context of the layover, we can talk about it in great detail as well. Anyway, we systematically do that. That's a standard and an expectation, at least in my company, and I believe that's pretty much par for the course. The expectation is pilots will critique themselves after an event. I've gone to the extent sometimes where I'm having difficulties communicating with a dispatcher, and I call the dispatcher after the flight and say, in this situation, I was trying to do this, you were trying to do that, what happened there? What did you see that I didn't see? And you know, I even take it to that level. That's just how I do it. But between pilots, we systematically, and the peer, it's not pressure. The peer awareness and the trust is absolutely the gold of the operation. It's really what's the thing that's going to hold it together when things go wrong, when things are unexpected. And when you establish that teamwork, both in the ops normal as well as things ops exceptional.
So do pilots get an opportunity, like let's say they're not efficient at something, do they get an opportunity to raise their hand and say, hey, I think I need some extra sim training, or?
Yes.
And that's looked upon as good and
it's
okay.
It's non-punitive. Now, yeah, you're going to get some raised eyebrows with resource managers who have highly extended training programs, and I go, he wants to do what? Yes, but it does happen. And pilots can also ask to fly with, I happen to be a line check airman, so you can call it like a turbo captain. I get to train people who are brand new. So I take those guys that Frank mentioned earlier who've never flown the airplane, the real airplane, and on a revenue flight. Guess what? Those people experience that guy's first landing, you know, and I'm confident in that system. I go in there and it's amazing. It's very effective. So they can ask for that, and also sometimes people end up in that situation with remedial training as a result of a deficiency identified in a training program, a qualification program, where sure enough an examiner says, hey, you need to work on this, and you're not allowed to go fly again until you get remedial training. You can take that in a lot of different ways, but they cast it as a positive. You're not fired. We're going to get you retrained and you bring you back up to speed. So there's a systematic way that we do it, at least at my company, and I think that's the expectation for qualification programs. Now, there are times when you go to extremes. I've been involved with training in our company, monitoring that for 15 years. I know of 2 exceptions where guys were having severe emotional issues, and they self-eliminated. They realized they're not supposed to be here anymore. And you know, that took patience, and that took time. All right, so sorry, maybe too much talk there, but that's, hopefully that answers your question. It's a big part of our culture.
It is. Certainly there's a drastic difference in the way it's viewed.
So we have just a couple minutes, so I just want to touch on this question that has a lot of votes on it. The FAA appears to be taking an increasingly ICAO-based stance on flight operations in general. Phraseology, flight plans, et cetera. What do stakeholders, pilots and controllers, think about these changes? Will we eventually have one global air traffic language?
You know,
I think that is where we are headed. I honestly do. And I don't think it's a bad thing. It's a paradigm shift. It's a shift in mentality. They have good things. We have good things. I think the less differences we have from flying internationally, even domestically, between our own facilities, the less chance we have for anything to go wrong. As long as everybody's on the exact same page, you hear clear for takeoff here, it means clear for takeoff. You hear go around, it means go around. Those are the given. Those are the facts. And then you have other ones where you say, cancel your takeoff clearance or stop, stop, stop. You know, there's 2 different things. They mean the exact same thing, but, you know, one region says something, another region says something else.
So this panel is one of my favorites because it's one thing that we want you to be able to hear it today, take it back to your facility tomorrow, and understand it and tell everybody else. And tell everybody what you have learned up here with these pilots and their experiences. So just one last thing, because we're pretty much out of time. I want to know what you want the other side to know. So I want the pilots to tell us what you want the controllers to know. And I want the controllers to tell the pilots just one thing that you want the other side to know. So we'll start with Don.
We are on your team. We think of you as a total essential part of what we do, and we welcome input and direction from you. And we in good faith, try to follow and go where you tell us to go.
I would say don't hesitate. I'd ask pilots not to hesitate to ask a question. What altitude did you clear me to, or what was that fix again? And make sure we clear up any questions.
And I'll go so far as to say that there is not a single day that I've showed up for work, and any with one I've worked with, that our intention is to try to make your day at work less enjoyable and more difficult. We promise, we're trying. And in comment to what Don said, you do not understand that in that cockpit, you are one of our resources, that every emergency we train, everything we do, you become a part of that solution, and trust us, it is not unappreciated. It's a big deal. Thank you.
Yeah, I think I'd say it's most important for the pilots to know that we have your best interest in mind, and that's why we do the safest, most efficient operation in the world. We're here for you, we're here for the public, and we appreciate what you guys do, so thank you.
Thank you.
Follow
that. If you guys have a plan for us on the flight, like you know you're going to take us from one intersection and skip a few, and tell us as soon as you know. We're not going to get mad if you change the plan. But the more you tell us what your plan is or what you're thinking, the better we can assist you and help your plan work if you just let us know ahead of time. And we won't be mad if it changes.
And mine is just follow up to that, communicate. Pilot's job is to fly the airplane, the controller's job is to separate. So if we know what you're doing or what you can and can't do, we can make that happen. So,
thank you.
I want to thank the panel, and I'll actually dismiss you at this point. Please give them a round of applause.